Hey everybody, this is your lecture for lesson 5. So, the big deal that we're working on today is a conditionals explorer. So, what is a conditional statement? It allows for specific conditions for when the code is to be executed. I'll give you an example of that shortly. It only works if the condition evaluates to true. I'll give you more examples of that later. And we can have multiple conditions to check against, and we can have multiple conditions that only one must be met. So we'll see examples of this throughout our slides. Okay, so how are Booleans, which is what we're going to talk about extensively today, and conditional statements related? So all conditional statements evaluate to either true or false, a Boolean. If the condition is true, then do the code that follows in the curly braces. That's it. So I like to think of conditional statements as gateways to let you into code. And I'm going to do an example on the next slide. So there's this meme with Gandalf because he's, fighting the Balrog, and he says, "You shall not pass," like several times. And so if you do not study, so this is this in code. So var study, so var is our keyword for variable. The variable name is study. We've set it with the assignment operator to the value of true. Okay, note that true is not in quotes. It's a Boolean value. So if study is equal to, see the comparison there? So we have the double equals, true. So if study is equal to true, which it currently is, then you can pass. So see the curly braces that follow that set of parentheses? I had a student refer to the parentheses as necessary pieces of information. So that is what allows it to go into that curly brace. If study was set to false, then it would you would fail, basically. So that's kind of a very brief overview. So let's take a look at this. Remember that numbers and strings, right? We have two different data types. We're now talking about a third data type called a Boolean. So, these are digits. They don't need quotes unless you want to make them a character instead of a number. Quotes, basically. So see how this 1, 2, 3, this is a set of characters, a character number 1, a character number 2, a character number 3 together as a string. That's how numbers work if they are strings. But we want to have numbers as opposed to like number of characters. Or we want to have characters, right? For the most part. If we're going to do anything like adding, we want numbers. Okay, Booleans, this is our third type of data that we're going to explore, are true or false. That's it. So, what do you guys think? 3 is 3 less than 8? Yes. 3 is less than 8. So that evaluates to being true. This is how comparison operators work. We're going to see about that next. So it's a clue that we need to stop and evaluate for a Boolean value. Less than, greater than, equal to, less than or equal to, etc., etc. And then the bang operator, that's the exclamation point. Basically, are these two things not equal? So each side of the comparison must be reduced to one value before we can compare. So 3 plus 6 is 9. Is that less than 8? No, it is not less than 8. 9 is not less than 8. So, I mean, it tells you to do this, but I'm kind of going through this process with you so you guys understand it. So 6 minus 3, is that less than 4 plus 1? Sure looks like it. How about 12 divided by 6? Yeah. So that's false because 2 is not greater than 3. Is that less than or equal to 10? Nope. 9 plus 5, is that equal to 4 plus 10? Sure looks like it. All right. So this is the comparison operator. And it basically says, if this is true, right? That's all it's doing. All Booleans do this. They render to true or false. So here, and we could have these in variables also, right? So if lives is equal to 5 and we add 4 to it, what is the value? It's 9. If score is 10, so we basically put the score here. See how that works? Minus 1, they're both 9. Is 9 less than 9? No, it is not. Any expression that can be evaluated for true or false is known as a Boolean expression. And in our conditional statements, those conditional statements render to true or false. That's it. Can I go to the movies if I'm allowed to if it's before 8 o'clock? So what information do I need to know? The following, right? So time is 9 o'clock. It's 9 o'clock. Can I go to the movies? Well, if the value of time is 9, is 9 less than 8? No, it isn't. It's going to stop and evaluate. 9 is not less than 8. Yep. So then we go to false, and I can't go to the movies. Wah, wah. So here we go, right? Have I won the game? I have if my score times my lives is greater than 10. So what pieces of information do we need to know? It's telling you to create variables to store that information, give them names. Don't worry about that. And I'm your partner, so we're going to discuss what the Boolean will look like, what will be compared. So here we have score and lives. So test 1, if score equals 3 and lives equals 3, does that work? Then score times lives equals 9. Is that greater than 10? No. So then it would be false. I haven't won the game yet. If score is 1 and lives is 10, that's 10. Does that equal, or is that greater than 10? No, 10 is not greater than 10. So again, we're in the false category. Test 3, if score is minus 5 times lives 2, it would be negative 10. So definitely no, we have not won this game. Now think about what values you could put in there. So like if we have 4 lives and our score is 3, 3 times 4 is 12. Is 12 greater than 10? Yes, then you win the game. So is my dog older than me if his age is converted to human years? 1 dog year equals 7 human years. Okay. So what pieces of information do I need to know? How, maybe we have dog age and my age. Let's take a look at what the next slide is. So here we are, dog age, my age. Dog age times 7. So if our dog is 1 times 7, is it greater than my age? No, it is not. Most of you guys are older than 7, I would assume. So how about 2, 14? Probably not. How about 3, 21? Definitely. If your dog is 3 years old, then they would be older than you. So how about this one? And this is a logical comparison. Basically, both things must be true in order for this person to adopt a cat. So see the big and there? That says this must be true and this must be true in order for the condition to be right. So what information do I need to know? Well, number 1, I need to know if I have $40 or more, right? And if I'm over 14 years old. So that would be that. So here we go. Can I adopt a cat? So first we need to know how much money we have, and then we need to know how old we are. So if you are 17 years old and you have $39, what happens? So age is the first criteria that we're checking. It's 17. Is 17 greater than 14? Yes. So then we go to the true side. All right. Then we're going to check to see if money is equal to 40. Here they have equal to 40. It really should be greater than or equal to 40, because if you have, $50, you should be able to get a cat because you have at least 40. But that's another thing here nor there. So 39 equal to 40? No, it is not. So we cannot adopt a cat. So that's how these kind of operators work. So these are what are called logical operators. So the two ampersands is and, the two pipes is or, and the bang operator is not. So when we have a logical operator, this would render out as false because this value, whatever it is rendered as true, and this value, whatever it is rendered as false. If something is true and false, it evaluates to false. All right, we're going to take a look at what's called truth tables. So true and true equals true. True and false equals false. False and true equals false. False and false equals false. So basically, both things need to be true. That's how you can render something in one conditional statement and still check against multiple conditions. Yep, both must be true. So the pipes, true or true, as long as one of these is true, it'll evaluate to true. True and false also evaluates to true. False and true evaluates to true. And then false and false, if both items are false, neither are true, then the whole thing evaluates to false. So I like to think of this as long as one item is true, the whole thing is true. Because it's an or. Is this true or is this other thing true? If either of them are true, then you get to pass. So either may be true for the Boolean expression to evaluate as true. And an interesting thing to note is that the computer will look at the first value, and if it's true, it doesn't even bother evaluating the second thing. It just goes right through. If the first value is false, then it will evaluate the second value to see if it's true. And if it's true, it will go through. So the not table, basically, not true evaluates to false. Not false evaluates to true. As the bang operator is what that's called. So using logical operators to combine several Boolean expressions into one expression, can I adopt a cat if I have $40 and I am over 14 years old? So here they changed, actually, no, it's still there. It's still the double equals. So we have to have exactly $40. We can't have 41. We can't have 39. We can't have 50. It has to be $40. So here we go. I'm 15 and I have $40. So here we are. Money is equal to 40. Age is equal to 15. Here we're going to check. Is money equal to 40? Yes. Is age equal to 15, greater than 14? Yes. Then it's true and true. So both things are true. We can adopt a cat. Some key takeaways that you need to know. A Boolean value is a data type that's either true or false. That's it. We take comparison operators. So 10 is not less than 2. It evaluates to false. 4 is equal to 4. That evaluates to true. And mind you, these values could be stored in variables. So comparison operators, right, indicate a Boolean expression. Each side of the Boolean is reduced to a single value, and single values are compared, and the results are a Boolean value of some kind, either true or false. Boolean expressions can also include logical operators, the ampersand, the or, and the bang operator, and or not. Both sides of the logical operator are reduced to a single value. So basically true and false, right, evaluates to false. True or false evaluates to true. Truth table can be used to evaluate the reduced expression, and a decision is made with a single Boolean value. Flowcharts are the bomb, I gotta tell you, because they help you see the logic and see what should happen under which specific condition. I'll go over that with you guys. That's pretty much it. If you have any questions, let me know. And as always, guys, happy coding.